thanks everyone for joining us today. My name is Mattia Santi. I am a co-founder of SASI Studio. And thanks to ArchiNet, first of all, for inviting me to present here today. We will talk about contemporary trends in facade design, discussing relevant case studies, and I will give you an overview of our design approach in this field. Our practice, SASI Studio, is based in London and Rome. We work on projects at different scale, from product design to interior design to larger real estate developments. Our team has a wide range of experience working with our winning practices like Zaha Hadid Architects, Farshid Partners, Farshid Moussavi Architects, Alvisi Kirimoto Partners. We gain our experience working on a wide range of projects, including residential, commercial, and cultural buildings, mixed-use development, and others. In most of these projects, we always had to deal with the facade of a building, the surface that determines the inhabitable space. The envelope of a building works as a transition between inside and outside and plays an essential role in the performance of a building. First of all, it provides protection, but also its aesthetics and cultural function are very important aspects that determine the success of the building. Like the skin of animals and people, architectural envelopes represent an essential element to create contained and protected spaces that respond to specific functional requirements. Our industry is in continuous evolution, driven by technological innovation, social changes, economical factors, and the design strategies are constantly evolving to meet the requirements determined by society and environment. Building skin design has a long history that goes in parallel with the invention of new technologies and materials and the evolution of our society. For example, the invention of glass by Egyptian and Mesopotamians allowed the Romans to create windows, and Venetian became master in the use of this material, and during the Middle Ages, the techniques of making glass evolved, and there was a large diffusion of stained glass windows. Another example of facade evolution determined by environmental conditions are the traditional wind catcher towers, structural components, part of the architectural envelope that allow the introduction of outside airflow into the interiors, creating a natural airflow circulation that acts as a passive natural ventilation system without the need of mechanical ventilation. During the Industrial Revolution, new materials and technologies were introduced, and this deeply impacted the architecture and design of building envelopes. An example is the construction of the Crystal Palace at the Great Exhibition of Works of Industry of All Nations in 1851. The building was designed by the botanist and greenhouse builder, Joseph Paxton, and the building hosted the first World Expo. The facade of this building is interesting because it was the manifesto for a country that was about to show its industrial power at the Great Exhibition, but definitely and became definitely an icon of a new way of making architecture. With the advent of modernism, the external appearance of the building changed, taking account of both technological and social innovation. The architectural skin becomes more and more transparent, performing the function of separation between interiors and exteriors, and not carrying vertical loads of the building. The postmodernist experimentation, again influenced by new available technology and understanding of structural behavior, found new ways to express contemporary society through the design of architecture skins. We can think about the Snowdon aviary at London Zoo, designed by the English architect and theorist Cedric Price, in collaboration with Frank Newby and Lord Snowdon, and completed in 1962. The design for the Fan Palace is another example because it proposes a building that becomes an interactive and adaptable educational and cultural complex. Other interesting example of this innovation that introduce new logic of performance and material behavior in the way we design buildings envelope are, for example, the structural prefabrication system introduced by Pierluigi Nervi that finds its mature expression in projects like the Palazzetto dello Sport in Rome, or other very important example like the works of Reiotto, that in the German pavilion for the Expo of 1967, he created an extraordinary tensile skin, result of a totally new experimental approach related to material behavior and form finding. Other example of revolutionary approach in facade design are the Centre Pompidou by Renzo Piano and Rogers and the Hong Kong Bank by Foster, in which the buildings are conceived as machine, and this completely change and affects the way the facade is designed and the relationship between the exterior and interior space. In parallel to this design evolution, other theories were coming out in adjacent fields, especially the work of the mathematician and philosopher Norbert Wiener, who introduced cybernetics theory, the science of communication as it relates to living things and machines, with implication for engineering, computer science, biology, neuroscience, architecture, and organization of society in general. His work theorized that the intelligent behavior was the result of feedback mechanisms that could possibly be simulated by machines, and was an important early step towards the development of modern artificial intelligence. This theory had an important impact also in the world of experimental architecture. One example are machine readable models developed by John and Julia Fraser. In this project, the embedded electronics allowed machines to read geometrical spatial configuration for the physical components. An interesting example is the Walter Seagal self-builder design kit developed in collaboration with John and Julia Fraser that allowed the user to self-configure the design the partition and the facade of their home, and the computer was capable to read this configuration and translate them in a virtual environment. These experiments are first attempts of a technological evolution that is affecting contemporary society, including the way we design facade in our buildings. Current facade design is strongly affected by new technologies. In the field of construction, for example, artificial intelligence, digital fabrication represent a new opportunity that can deeply change the way we build, reducing costs and increasing also safety. This innovation is also supported by new design technologies based on digital twins and algorithmic design that play an essential role in the evolution of facade design. We can see on the left in this screen, in this image, the grasshopper definition for the facade of the Morpheus Hotel designed by Zaha Hadid Architects, and on the right, one of the structural details of this building. Thanks to this tool, large quantities of data can be managed and used for project coordination. In fact, algorithmic design allows to manage complex design ideas and solve multi-objective design issues, taking in account information relative to multiple stakeholders, for example, planning regulation, environmental condition, and user behavior. This technology opens the possibility to improve design quality by accessing and considering different types of project information from early stage of design. Of course, another essential aspect to be considered in contemporary facade design is sustainability. In fact, the fundamental aim of a building is to protect people from external climate conditions. Building skin is the primary subsystem through which external conditions can be influenced and regulated to meet comfort requirements of a user inside the building. The main challenge is to respond to multiple functional performances, shading versus artificial lighting, views versus privacy, solar gains versus overheating. Contemporary performance requirements for facade brought the development of adaptive facade system that are some of the major trends in contemporary facade design. This system can contribute to energy savings by adapting its components to boundary conditions in order to create active or passive reactions that allow for adaptability. Adaptability can be interpreted as the potential of the system to deliver multi-objective comfort criteria under certain environmental conditions by changing its physical characteristics within a short time frame. We can identify some main topologies using contemporary scheme design, from kinetic facade that use, for example, mechanical transformation to respond to changes in the environment, to biomimetic facade that implement behaviors observed in natural systems, like, for example, the high skin pavilion that changes its configuration thanks to changes in the humidity level. And or other example, like, for example, interactive facades that integrate advanced sensor and microcontrollers to interact with the user and learn from the user and teach to the user to improve their behavior and use of the built environment. This is just to mention some of them. The research in this field is constantly evolving, and there will be also this classification, categorization has a lot of blur boundaries, but these represent some of the latest tendencies in this field. While I will now talk about one building in which I had the chance to work on while I was working at Zaha Hadid Architects that represent one example of these categories. This is the Generali Tower in Milan, an office tower with a commercial podium. This project is an interesting example of a double skin facade, and it is a part of the city life development and is part of Milan cityscape. The tower is approximately 170 meters of height with approximately 40,500 square meters of cladding area, with a total of 6 different types of cladding. The entire design is generated by centripetal forces generated by the intersection of 3 main axes that converge at the base of the building. The vortex of centripetal forces starts at ground level and continues at the upper floors. The towers excels in respect of international benchmarks for efficiency while respecting Milan rigorous building code. This building is in fact characterized by a double facade with sun deflecting louvers, offering an efficient environmental control for each floor and ensures excellent energy performance, contributing to the Generali Tower LEED Platinum assigned by US Green Building Council. The inclined perimeter columns follow the twisted geometry of the tower to align with the external facade units. The outer skin follows the twisted form of the building and requires cold bended glass, while the inner skin follows a faceted form that best approximates the flowing of the outer form. The facade is conceived as an externally ventilated double skin facade in which the terminal line is set to flow the setting out of the inner, to follow the setting out of the inner glazing line. This project is an interesting example of the use of double skin facade and shows how it is possible, thanks to this facade strategy, to drastically improve the energy performance of the building. I invite everyone that will be in Milan to visit this building because it's a very interesting architecture. Another interesting example that I would like to talk about is the exoskeleton facade. An extraordinary example of this typology is the Morpheus Hotel at the City of Dreams in Macau, designed by Zaha Hadid Architects. The building is characterized by a complex geometry with a wide opening connected by bridges that connect the hotel's interior communal spaces. The Morpheus houses 770 guest rooms, suites, and sky villas. Includes civic spaces, meetings and event facilities, gaming rooms, lobby, restaurant, spa, and there is also a rooftop pool. The tower represents is very interesting because it represented the world's first free-form high-rise exoskeleton. The exoskeleton basically is an exposed structural system that becomes part of the facade. And the facade has been engineered by Bioreactor, and the complexity of the 3D connection and forces distribution required to study the entire system as a unique piece and to study its structural behavior. The Bioreactor team has to use a finite element analysis in order to understand the complex behavior these multiple nodes were creating in this facade. This building required basically to use the software at the limits of their capabilities to handle large quantity of complex data, creating new challenges not only for the design, but also for the way we manage and deliver the design. In addition, in terms of facade, high performance glazing, in this case, minimizes solar gain, and the ridging of the exoskeleton provide shading. In this complex facade project, as you can see, plays an essential role the computational design tools that are used to manage the overall design, because allow the designer to manage the geometrical complexity thanks to the use of algorithms and digital twins, creating important information and documents that then simplify or let's say become essential for the construction process. Another example that another important case study that I would like to talk about in regards of contemporary facade design is the Alai complex by Zaha Hadid Architects that is located in the Mayan Riviera and in the area of Cancun in Mexico. The development consists of 7 residential towers and a podium. On the podium has a multi levels, and on the podium there are several amenities, and becomes the trade union of the different towers. The location, the distribution of the different towers was studied thanks to solar analysis to maximize the hours of sun on the podium, and at the same time optimize the views and the arrangement of the overall towers. And I wanted to talk about this project. I had the chance to work on the facade design of this project while working at Zaha Hadid Architects, because it's very interesting in terms of facade design strategy. In fact, the project represents a modular facade system that integrate, basically, that work across 7 towers. The 7 towers are designed, in fact, using repeated modular components that can be built with a small amount of formworks. Having basically the entire modular facade system allows to create a lot of complex facade variation across the 7 towers, but at the same time allows to drastically reduce the number of different components, also having an important positive impact in the construction cost. And this happens thanks to these repeatable elements of the facade that can be rotated and connected or mirrored or moved of position, creating this sort of combinatorics effect. Also, the facade design of this building is very interesting because integrates natural materials to better integrate with the natural landscape and provide a natural shading to the residential unit. This example is interesting because of course it's a modular design approach that becomes very cost effective when it's combined with digital fabrication strategies and off-site manufacturing. In fact, these technologies represent an important contemporary trend in facade design and can be a revolutionary technology for future facade design. In fact, by adopting off-site manufacturing technologies, it is possible to have a positive, an important positive impact on sustainability by reducing carbon emissions and as well increasing safety in the construction process. But of course, in order to enable these technologies, we need to have a sort of design like this one that allows to then enable and apply construction logics because they have been already integrated in the design from the first moment, from the early concept of the design. So in these, these are 3 case studies that are part of my are part of let's say recent trends in facade design, and they are I think quite representative in terms of innovative approach in facade design. And I would like to talk about a bit more of how this, I mean, what is the approach that we have as a SASI Studio, and introduce a bit more about our interest for investigating architectural skin as opportunity to create new living experiences where people are connected with the natural environment, and the design strategy takes advantage of contemporary technologies to facilitate construction and help clients in achieving a good balance between design innovation and budget. I would like to talk about the Volts Tower that for us represent an interesting concept design proposal in which we investigated the use of volumetric facade elements. The system integrates the structure, and these bolts becomes thermal mass. Basically, these are inverted bolts that generate an articulated balcony system, offering to the user open spaces that can host vegetation along the entire height of the tower, creating a sort of vertical forest effect. Each bolt basically encloses a certain volume that becomes, as I said before, a thermal mass, and this contributes to the overall temperature control of the building and creates a wide open space as well for the users that of course is a unique experience, especially when you design a tower like this in a dense city center where general user don't have cannot access a lot of open space in a high-rise building. Of course, the design of these balconies is strongly affected also by the wind speed in the areas, and this is definitely depends and varies region by region. In the middle of the tower, we design a double height amenity level that offers multifunctional spaces for the inhabitants of the building. This is an interesting approach that we want to have in facade design, where that affects the overall organization of the layout of the building. In fact, in the middle of the building, we introduce a floor that becomes a sort of preview for the entire usage of the tower by the people that inhabit the tower. And this space offer public amenities, can offer study rooms, can offer work from home spaces, or can offer just spaces for social interaction. This innovative distribution in the tower layout is reflected in the design of the skin. But the interesting thing that happened in this design, and I would like to underline, is that we managed to achieve this lobby level without having to increase multiple different facade components. In fact, As you can notice, with a few additional elements, we managed to use the same system to generate this special condition in the facade design. In fact, the entire system is made of repeated components. This is the model that you can see in the video. That creates the entire articulation of the facade, in which each user has its own intimate space. The walls are designed as simple curvature surface that can be fabricated off-site and then assembled on-site. The idea is to have, let's say, this complex geometry built with single curvature surfaces that allow to reduce fabrication costs and especially allow these components to be rotated multiple times and use the formwork to build many different components that then can create the different special condition of the facade. This facade articulation reflects in the interior topologies organization that are repeated every 2 floors, optimizing the distribution of the interior layouts and creating in the middle, as I was mentioning before, this multi-level double height lobby space that is, let's say, an exception within the overall design of the building and creates this sort of meeting point for the entire tower. Another example, another project that we recently developed is our proposal for the Gwangju City main library in South Korea. This is for us an interesting example of facade design because the project basically consists of 2 parts. One is the one on the left that you can see in the left side of the image that was that included an old industrial buildings that had to be renovated. And on the right side, we have the creation of new volumes for the library. In this project, the facade becomes the trade union of the entire volumetric distribution. In fact, the multiple buildings become part of an overall system, thanks that is thanks to the bridge connections that characterize this facade design. The entire facade, as you can see in this short animation, is designed by thanks to the use of algorithms that allow us to determine the exposure of the facade to the solar radiation along the year and allow us to create an algorithm that design and adapt the louver system to the actual solar conditions that we could analyze thanks to the in the virtual environment. The design follows, of course, the design of the facade and the louver system follows, of course, the overall movement of the volumes and offer passive shading that protect the different spaces of the library and the reading rooms from the solar radiation. To understand a bit more the logic that determines the design of this facade, I would like to show this section where basically we see how each volume is carved to create internal courtyard that brings light inside the space and at the same time offer enclosed communal gardens. These gardens are used to collect and recycle rainwater, but at the same time, like we saw in one of the previous examples at the beginning of the lecture, it is used to generate wind flow thanks to by creating a chimney effect and by using solar radiation that affects the side of the building and using the colder air inside of the courtyard to create a natural ventilation for the overall building. The idea for this project was basically to maximize the use of natural resources through a scheme design capable to regulate the natural ventilation, natural insulation, and creating also natural conditions for the allocation of solar panels that can contribute to the creation of new energy necessary to run the building. The project also makes use of geothermal energy and offers numerous green terraces that becomes transition space, thanks to the overall facade idea, that becomes transition spaces from inside and outside, offering like meeting points and spaces where people can meet and socialize. One of the last projects I would like to talk about is the Bradfield Tower. This is a recent proposal we developed for a tower in London, and is interesting in its simplicity. It's an interesting idea to create a mixed-use tower, inspired a bit by recent events that affect, I mean, everyone, in which many people are working from home, and then it requires to rethink the way we inhabit and we live our spaces, our homes. And therefore, we created a mixed-use development in which the residential function coexists with co-working spaces, private gym, and a rooftop bar. So basically, in the lower level, as you can see from the render, you can you have basically more communal spaces, like for example the gym or the co-working space, and then going up, these spaces become more private, and therefore these are used as residential spaces. While we arrive at the top of the tower, we can see the louver system that covers the rooftop bar. We can see this a bit better in this image, where we can see, for example, how the basement is characterized by 2 entrance lobbies and many retail spaces that are introduced in this project to create a 24-hour activation around the site. In the overall design of this building, the facade plays an essential role. In fact, the overall idea is to have a simple volume that is dictated by local building regulation, and there are some openings, some cuts in the volume to create the balconies, and again, as you saw in other of our projects, create some open air space for the users of the building to have this transition between outside exterior space and interior space. These terraces gives to the overall facade a certain dynamic movement by dematerializing the corners. The overall scheme and design is based on a modular cladding approach. All the elements are designed to be in aluminum. And although the facade has a certain articulated aesthetics, is actually quite well optimized in terms of construction costs. In fact, the overall design of the facade is basically, as you can see in this image, by mainly one complex module that is actually repeated across the entire tower. So this allows us to create this sort of game about shifting the position of the plane, creating articulation in the floor plan, but at the same time allow us to reduce and keep the budget of this facade within certain tolerances and within certain margin of cost. Thanks to the fact that this is basically one single element that is repeated across the different part of the tower. In general, in our design approach, we design facade as 3D systems that respond to multifunctional requirements and take in account construction strategies from early stage of design. We don't expect to develop design across stages before we start thinking how we are going to build it. We take this in account as part of the design strategies, because we believe this makes the design much more flexible, and also allows to create a much more linear flow of the overall project management and design. In general, apart from this project we have been recently working on, we are an experimental practice as well. We believe in innovation, and we invest in research and academic collaborations. We are interested especially in digital fabrication as an opportunity for the construction industry that can be used actually to increase the quality of the design without proportionally increasing the cost. In fact, thanks to computer numerical control machines and robotics, we can create a complex geometry and use innovative materials to enable design solution that previously would be expensive and difficult to implement. These machines allow to translate digital twins in the physical environment, create a bridge between the digital world and the physical world. This, for us, opens up to new opportunities in facade design, as well in general in the construction industry. We believe that architectural themes will they already play an essential role in our cities, but even more in the future, they will become major players in the city of the futures. In fact, the idea of architecture space, we believe, will extend beyond the limit of the envelope of the single individual buildings to create more shared space, more multifunctional spaces that can be shared by the community, and will be able to respond to multiple functional requirements. And especially, this space will be essential for cities because they will become flexible spaces that can respond to different user scenarios. We see some of the example of facade that we think play an essential role at urban scale. And we believe that in the future, local authorities and public authorities will invest and should invest more and more in this type of infrastructure that create unique experience inside our cities. But the idea of inhabitable space in general, for us, goes beyond the idea of high performance envelope. We believe that in future they will become more metaphysical user interface that will interact with the user, offering new dynamic spaces similar to how we interact with our smartphone or other digital tools. And this will allow to create a new concept of facade that will become an interface between the building and the user. With this, I would like to conclude for today. And I would like to thank everyone for joining us today. And I will be available for any question about the...
So we have a question. How does these ideas get incorporated into the existing landscape that surrounds them?
Generally, I mean, the relationship between the design, of course, like designing the facade of a building is basically designing an interface between the city and that specific building. And the relationship between the building and the context can have can take different approaches. Sometimes you want to integrate with the existing context. So somehow, for example, as we saw in some of the previous example, like in the Ally project, you have a selection of materials, or you have, for example, selection of a design strategy that can well integrate with the, for example, natural environment or the landscape. In other cases, like for example, I may consider the Bradfield Tower. Bradfield Tower represents an example in which we want to detach from the existing context. At the same time, taking into account, for example, the presence of a railway, and therefore we bring back the existing element, the steel, the iron of the railway in the design, in the selection of the material for the facade. But definitely, for example, in that example, we want to create and inspire a renovation for the entire area. So the way we design that facade is we try to have a different approach in relation to in comparison to the other buildings in the neighborhood. But this strongly depends on the type of urban texture you are working on. There are, like as I just said, like there are some urban textures that already have been renovated and they already have a strong characteristics that we want to emphasize. And then the design of the facade through the geometry and through the materials and through the interaction that they can establish with the people could create a collaborative approach with technology. While other cases where you want to change, you want to stimulate transformation, you should basically have a design that actually will represent this change and will sort of suggest this innovation. I hope I answered to the question.
Yeah. So the second question from Manar, she says that the facade design looks like highly connected to the performance of the building. So from your experience in these projects, how has that affected the human comfort and post-occupancy performance of the building?
Yeah, I mean, it's a very good question, and definitely yes. I mean, facade is definitely connected with the building, as well as our skin is protecting our body from the external environment and help us to keep a certain temperature, establish a certain interaction and communication with the external environment. In a similar way, the way we design the facades drastically affect the level of temperature inside the building, the level of humidity inside the building. It can drastically affect even the feeling we have of the space. In fact, as I showed before, there are a lot of contemporary systems that study this relationship between facade and interior space, and there are different ways in which the design strategy can affect and guarantee the comfort inside the space. As I said before, there are facades that just offer passive system, like for example, double skin facade, like the example I showed about the tower in Milan, that basically use natural ventilation to create this transition and guarantee a thermal comfort, and as well guarantee a thermal comfort that can be separated floor by floor, therefore strongly affecting not only the comfort of the people living inside, but also the management of the system and the cost of managing the system from the owner of the building or the society that manage the building. On the other side, there are a lot of recent research that works with facades that are able to monitor through sensor and microactivators the internal and external condition, and also can map the behavior of users. So they basically use artificial intelligence to actually understand how people move and react to certain facade environmental conditions, and they adapt the facade or whatever is the system that this automatization can control, to actually support and select those configuration and those parameters that that promote better behavior of the users. So basically, there is no more like a static facade or let's say, facade that just respond to our requirements, but there are facades that actually can interact with us and can become, let's say, system that not only respond to our requirement, but also help to educate us in the way we use the building. So I think facade design is definitely one of the most exciting grounds for combination of latest material innovation, latest technology in artificial intelligence and automation design, and at the same time, they become a very exciting ground for designers to experiment. And the design is no more only about a specific geometrical configuration, but about the design of a behavior. We are actually designing the behavior of our overall system, and how, I mean, this behavior is influencing our comfort inside the building in terms of temperature, in terms of lighting condition, in terms of humidity levels, in terms of even communication with the exterior. And as well, there are a lot of innovative projects that go in the field of media facade, where you know, the building is also able to play a infographs and communication role, a different role within the urban context. Let's say the comfort, or let's say the experience, is not only about what is inside the building, but also the immediate context.
Mm-hmm. So the third question, we still have about 4 questions. The third one is from Dr. Abir. Buildings today work as a system with the facade as the only part of it, focusing on your designs on that part rather than the whole might have significant effects on the workability of the whole system. What do you think?
Yeah, I totally agree. I totally agree on this point of view. And I believe that I mean, this is a very good observation, because buildings are systems, and as I showed before, for example, the project of the Fun Palace, or some of the works about cybernetics, or even like Centre Pompidou or other buildings like this that I showed before in the lecture, they are architecture machines. And as architecture machines, they by definition become systems that can respond to different type of configuration, different type of parameters. And in this sense, it's very important to think about the building as a system when you are designing, because you are no more designing a specific object or a specific state or a specific geometric configuration, but you are designing a system that has one behavior, two behavior, three behaviors, and you need to take in account time and multiple stakeholders. So, and this is very important, and also because today is possible, thanks to the new tools we have in terms of design. We can think about a lot of algorithmic software that allow us to create not only a geometry, but design system that can respond to different parameters. So you basically can actually design and visualize the kinematics of the building. You can see how the building responds to certain parameter. You can plug, while you design, data that comes from different contexts. For example, you can run a wind simulation and have that running while you update your design, and observe how for example, the changes you do in the design changes the behavior and the interaction between the building, the urban context, and the certain environmental conditions, wind, sun, or other factors like this. So yes, it's the design of a facade and the building is the design of a system that has very different layers that need to be managed, controlled, and conceived as a system from the first moment in which you are starting the design and the idea.
Okay, so we have the fourth question from Mu'taz regarding the residential tower in London. Does the inclined element of the facade play any structural part?
No, as you saw in some of other, I mean, as it happened with the evolution, for example, of curtain walls, like some of these systems. I mean, I show some system like the exoskeleton where the facade actually has a structural role. But in this case, in the example of Bradfield Tower, that doesn't have any structural role. The entire structure is resolved by a traditional, very simple and traditional structure, but becomes design features that articulate the interior layout. So it doesn't play a role as a structural element, but it plays a role as a compositional element. So influence the distribution of the spaces inside the building.
Okay, the fifth question from Dr. Lama regarding the large amount of glass on facades might increase the cost on heating or cooling the buildings. What sustainable solutions we're taking to resolve this issue?
Yeah, this is definitely a good question, and it's definitely a very good point. In general, it's true, glass facade can increase, of course, the overheating or the dispersion of heat from the building. And as I mentioned, there are different adaptive facade systems, for example, just to mention some of the contemporary ones. But the main categorization is between passive and active facade systems. So active systems basically tend to respond to certain variation in the environment and provide, for example, shading or mechanical device that can create shading to reduce the solar exposition. Or, for example, we can use a facade that change the physical state. So basically, facade you can switch on and off, and we basically, thanks to the use of specific gas activated by electricity within the double layer of the glass, you can basically control the amount of light that goes inside. There are like other facade, like the big project that is the first bioreactor facade, in which basically you use algae. Is one of the projects that was within the example of adaptive facade system, and basically is this type of facade system where you use actually the facade to generate energies. Other system, of course, like integrates photovoltaic system in the facade. So what you lose on one side, you gain on the other by recovering energy. But what I find very interesting is the passive approach, in which, for example, the like the Generali towers and that use the natural, I mean, the physics and the natural behavior of air, for example, to reduce without the need of any high level or high technological or any mechanical system to actually reduce the heating of the building, and allows to create a natural ventilation that is not activated. It can have some mechanical activation in certain cases, but in many cases we manage to achieve that ventilation without the need of support for mechanical devices. So these are interesting systems that are activated by the natural behavior, natural laws of thermodynamics, and they are a very smart system because they take advantage of basically law of physics to create optimized living environment and reducing with very low energy requirements. I hope I gave a kind of wide response to this question.
Okay, we have a question from Harith on term of using 3D printing. What the obstacles that facing the constructor or the constructor execution for the facade of the building?
I mean, 3D printing, there is a huge amount of research going on in 3D printing. Major universities across the world are experimenting in 3D printing. Some of the research in 3D printing is related to actually creating some self-structural component, etc. In terms of facade, there is a world of experimentation that we can try, because depends the way you design the facade. Not all the elements need to be structural elements. So this allows to create even panel system or smaller elements that can be assembled without necessarily having, let's say, a huge structural performance. Of course, there is always structural performance to keep the elements together for the facade. There is still always wind interaction, seismic behavior, so still needs to have this level of integration. But one element that probably we need to consider is the materials we can use for 3D printing. In fact, for example, one of the limits, one of the main considerations we have to do in terms of facade design is everything related to risk of fire, so fire insulation, and this is an important element to be considered in the way the type of material we select, and therefore its condition, since 3D printing still is possible with certain type of material, not with every type of material. This needs to be considered, or at least some materials also have a huge amount of plastic that could be a problem from a high risk point of view. So this is an aspect to be considered. But on the other side, we also need to consider that 3D printing, I mean, digital fabrication technology is not only 3D printing. And digital fabrication technology can be, for example, CNC, can be injection molding, can be rotomolding. And some of these technologies, when, for example, you need to create 1,000 of pieces that are all the same, may be more effective than 3D printing. Let's say if we have a facade in which there is a low degree of variation, you probably don't want to use 3D printing, because 3D printing as a fabrication system is not scalable, in the sense that if you need to print more, you need to have more printers, while and there is still a certain number of parts to be done in order to build that piece. While, for example, if you need to build many pieces that are all the same, and you have, for example, a thermovacuum forming or injection molding, you can create a sum of these elements in few seconds, and then you can create thousands of pieces in few seconds. So depends how the 3D printing is actually made, what type of machine you have to do 3D printing, and depends as well on the type of design you're working on. But if, for example, it's a design where there is a lot of variation, a lot of complex articulation, definitely 3D printing or other robotic-based fabrication strategies could have a major impact and could be a very good strategy, because in that case, they allow to reduce a lot. They don't require any formwork, so they reduce a lot of cost, and they may enable a building that would be super expensive if you have to build, many formwork or formwork for each element of the facade. So I would suggest, I mean, the answer to this question, I would suggest it really depends on the design you are trying to develop, and at the same time, the type of 3D printing technology you can access. Definitely is an extraordinary tool for testing and for designing and to try different complex articulation of facade. And definitely from that point of view, is always an amazing tool. I hope I fully answered this question as well.
Yeah, thank you. We there is one question very long, so we decided to go as a voice for this question, because it's actually it's repeating a couple of questions we have here. This is from Shireen. Shireen, you should have the mic now.
Hello.
Hi there. Good afternoon.
Thank you. Hello. Good afternoon to you.
Okay, I'm having a longer question here because I am interested a little bit in the critical thinking here. I mean, I was wondering about how to generate the concept of the composition of the surface architecture. So my question was, by mentioning the Crystal Palace at the beginning of the session, and carrying us through the adventure of the industrial revolution effect, ending with the post-modernity, of course, by surface architecture. I think it's easy to notice that elevations are starting to get completely detached from the plans to start growing as a scan, especially in building composition 3D. After the fractal theory, in fact, I think the fractal theory have this transition where architects started to flee the visual complexity from plans by algorithms. So I was wondering, really, by deconstructing elevations from a reasonable equation to plans, do you think that the challenge which the architect faces here is a classical individual challenge and composition, or should architects start to study deep enough into other science disciplines to become really capable of to develop new creations to future architecture? So are we witnessing here an analog return or direct metaphors maybe in creating new layouts? This was the first part of my question. The second part, if you allow me, of course, I was thinking about the smart material application and the implementation of the smart textiles, smart textures, and the nanotechnology, if it served this detachment and maintenance for those huge elevations and compositions. I mean, do we still have a guarantee for maintenance for these buildings as we have here in Jordan for 3 years in contracts? So I think it's the end of my question, and sorry for being so long in asking. Thanks a lot again.
Thanks for your question. It's very interesting, and I will respond basically in 3 main points in your question. I will start from the first point where you asked if the architects should go in understanding other disciplines and expand their domain of knowledge. In my vision, yes, definitely architects, architecture, as we noticed from before, I mean, even in history, like you think about Brunelleschi, they were building the, not only the domes, but they were also building the machines to actually build the dome. So architecture is a complex profession and requires to be multidisciplinary. Nowadays, we have a lot of latest technologies that we need to know to be able to actually make the best use of this technology and put them at the service of the design and the client. So yes, definitely we need to consider many different disciplines, from material science to computational design, robotics, digital fabrication. At the same time, in regards of the detachment of the facade from the interior layout, yes, this is something that, especially with the modernist movement, was part of the intention, and this happened. I mean, curtain wall was definitely the best example of this detachment between the interior layout and the exterior envelope in the facade of the building. In contemporary design, I think we are observing different of change of direction. A lot of contemporary designers, from Zaha Hadid to Kengo Kuma and others, they have a much more, let's say, a different approach to facade design, in which it is more three-dimensional. And I would like to include ourselves between architects that are interested in having a change in the way we design facade, because as you can notice in some of our buildings, we go beyond the idea of the just glass curtain wall that is just a, let's say, envelope superimposed to the overall 3D building. In fact, we actually start from in some of the projects, as you can see, we start from not the design of the overall, but the design of the element. We start from the component, and we articulate this component in a three-dimensional environment where, as you saw, for example, in the Vault Tower, the skin and the interior layout are strongly interconnected. And not only the facade design, but also in the structural design and the interior layout distribution, they become part of an overall unique system. And also, I think this is an important thing, because goes beyond the idea of the simple facade that is just the conclusion of the interior space, but becomes opens the opportunity for a more complex facade that creates transition space between inside that are some of the most useful and interesting experience that we can offer to our users. So definitely, I'm happy that you observed this trend, because it was the point of creating this historical evolution at the beginning of the presentation. And I hope that you can observe, I mean, in the last part of the presentation, how many of these facade systems I presented are actually creating volumetric facade system that becomes again very interconnected with the interior layout distribution of the building. And the last part of the question, just the second part of the question was more relative. Can you just help me on the second part?
The materials, actually.
Yeah. So in terms of material, thanks for the hint. So in terms of material, like for example, the aluminum facade that we are using for we propose for the Bradford Tower is an aluminum that, for example, is able to decompose. I mean, there are a lot of this type of aluminum that helps in terms of sustainability, because when molecules of pollution touch the aluminum thanks to water, basically the aluminum can decompose this molecule and reduce basically the pollution elements get attached to the aluminum, and then with the rain, the pollution basically is no more in the air, but it can flow away with the water. So this is, for example, an example of active materials that can improve the maintenance of the building. But also there are a lot of interesting materials, like self-repairing material. I know that one of the latest models for Lamborghini, for example, has the skin of the car is designed with nanotechnology that actually allowed the skin to self-repair in case of certain, scratch, or in case of certain specific problems. So in general, I think that looking at latest nanotechnologies for latest smart material is an essential element that will reduce a lot of the requirement for maintenance of the buildings, but can be, and these materials are coming out because they are part of a wider research that's not only affecting architecture, but is especially important for aerospace industry, is important for naval industry, is important for even car industry, and then real estate and architecture industry can borrow part of these technologies and can find application for this technology in our facade design. So definitely, I suggest to take these things in account, and the maintenance of a building should be taken in account from the early stage of design. In many cases, doesn't happen, but that creates problem later on for the maintenance of the building, and creates problems for the users that own the building, and also sometimes result in health and safety issues. So definitely, like even if without having innovative materials, we still always need to think about maintenance of the facade. But definitely nanomaterials and innovative materials can be important complementary support to contribute to the maintenance of the building. I hope I fully answered to the question. If there is any other point you would like to...
Actually, we will wrap up with that question, and thank you a lot for answering all of them and for this fabulous presentation.
Thank you. Thanks for having me today, and thanks for everyone for attending.
Thank you. Take care.
Thank you. Bye-bye.
Bye-bye.